In today's rapidly evolving technological landscape, the integration of remote control and teleservices into critical infrastructures and public utilities has become essential for efficient and intelligent energy management. Imagine a system where operators can monitor and control energy distribution networks from a centralized location, ensuring optimal performance and quick response to anomalies. This is the promise of intelligent energy management. It encompasses various elements, from system flexibility to the implementation of smart grids. A crucial aspect is the use of smart metering, which allows for precise monitoring and management of energy consumption. Additionally, flexible connection agreements enable utilities to adapt to varying energy demands more effectively. But there's more. Remote control systems, often utilizing programmable logic controllers, PLCs, automate processes and enhance operational efficiency. Industrial automation platforms provide a comprehensive environment for developing, simulating, and deploying these solutions. This leads us to the creation of smart grids, which use digital technology to improve the reliability, efficiency, and sustainability of electricity distribution. Smart grids enable two-way communication between the utility and its customers, allowing for better management of energy resources and more informed decision-making. Remote control systems are the backbone of modern energy management, enabling operators to oversee and manage critical infrastructures from a centralized location. These systems rely on programmable logic controllers, or PLCs, to automate processes and ensure optimal performance. Imagine a vast network of sensors and actuators communicating with a central control unit, all orchestrated by the PLCs. The PLCs execute predefined sequences of operations, adjusting parameters in real time to maintain efficiency. For instance, if a sensor detects a drop in voltage, the PLC can automatically adjust the load distribution to prevent an overload. This real-time adaptability is crucial for maintaining the reliability and efficiency of energy distribution networks. Moreover, these systems are designed to be scalable, allowing for the integration of new components and technologies as they emerge. The key to their effectiveness lies in the precise programming and configuration of the PLCs, which must be tailored to the specific needs of the infrastructure they serve. And here's why that matters. To implement remote control systems, you start by selecting the appropriate hardware. Choose a programmable logic controller, or PLC, that supports remote communication protocols such as Modbus or Ethernet/IP. Next, configure the PLC's IP address and ensure it's set to a static value for consistent remote access. In your industrial automation platform, create a new project and import the PLC's communication library. Define the data points you wish to monitor or control, such as temperature sensors or motor statuses. Use the platform's built-in functions to establish the communication link. Remember, the exact steps may vary depending on your specific PLC and platform, but the core principles remain the same. This setup allows operators to manage critical infrastructures from a centralized location, enhancing both efficiency and responsiveness. Now, let's delve into the execution phase of remote control systems. Picture this: a network of sensors and actuators spread across a city's infrastructure, all connected to a centralized control system. When an anomaly is detected, the system triggers a predefined sequence of actions. For instance, if a power surge is identified, the remote control logic will immediately adjust the load distribution to prevent an overload. This is achieved through programmable logic controllers, or PLCs, which execute the logic in real time. The key parameters here are response time and accuracy. Set the response time to under 200 milliseconds for critical actions to ensure swift reactions. Accuracy should be within a 1% margin of error to maintain system stability. Remember, the efficiency of these systems relies on the precision of these parameters. So, when you're configuring your remote control logic, pay close attention to these details to ensure optimal performance. Let's dive into the advanced nuances and optimization strategies for remote control systems. Imagine you're fine-tuning a high-performance engine. Each parameter adjustment can yield significant performance gains. In remote control systems, one key parameter to optimize is the communication interval. Reducing this interval can enhance real-time monitoring but may increase network load. Find the sweet spot by testing different intervals and monitoring system performance. Another crucial aspect is the use of data compression algorithms. These can reduce bandwidth usage without compromising data integrity. For instance, implementing LZ77 compression can decrease data size by up to 50%. Additionally, consider the use of quality of service (QoS) settings in your network configuration. Prioritizing critical data packets ensures that essential information reaches its destination promptly, even under high network traffic conditions. These advanced techniques not only enhance system performance but also contribute to a more resilient and efficient energy management framework. Now, let's dive into common pitfalls and debugging strategies for remote control systems. One frequent issue is communication latency, which can cause delays in data transmission. To mitigate this, ensure your network infrastructure is optimized. Use quality of service (QoS) settings to prioritize critical data packets. Another common problem is incorrect configuration of PLCs. Double-check your settings, especially the IP addresses and port numbers. Misconfigurations here can lead to system failures. For debugging, start with the basics, verify power supply and connections. Use diagnostic tools provided by your PLC manufacturer to identify errors. Remember, error codes are your best friends, they give you direct insights into what's wrong. Lastly, keep your software up to date. Firmware updates often contain critical bug fixes and improvements. By addressing these common pitfalls, you'll ensure a more stable and efficient remote control system.